In this question, we will find out an expression of the horizontal distance covered by the ball or any object which you have thrown at some angle theta, okay, with some velocity u. If it is known, you can find out the horizontal distance of this object. So what will be the trajectory of this ball when you will throw at this angle? So this ball will make this path. If there's a no air resistance, then we know that the ball will move with a constant horizontal velocity. And in fact, the horizontal velocity is actually responsible for its horizontal motion, because when you have thrown this ball with some energy, so it also have a horizontal component of kinetic energy, right? Means that kinetic energy is not a vector quantity, but it have some energy which will take it horizontally forward, and some energy will take this ball vertically upward. Okay, so we always utilize the vertical component of velocity to find out the height, and horizontal component of velocity to find out the horizontal distance. So we know that this is a u cos of theta, and how much horizontal distance will it cover? Let's find out with the help of SUAT. So this is a horizontal distance, let's call it x. Okay, we will apply SUAT, so we will utilize these values. So this is a horizontal component of velocity u cos of theta, and you see that the vertical velocity is small. At this point it's the same, u cos of theta. So why not we can apply this equation? Which one? S is equals to u plus v over 2 into t. And why not this equation? V square is equals to u square plus 2as. Now, I'm sure that you have an idea very well that we have to find out the final velocity. Okay, final velocity for this as well. So, but that is same. So if you have to utilize this equation, then you have to also find out the time. Okay, the general equation of the time. And if you want to use this equation, this will not make sense, because the x component of velocity and initial and vertical and final velocities are same, so both will cancel out eventually, and this equation will not give us a sense. In fact, it will prove you that ax is equal to 0, which we know very well that if there's a no air resistance, then ax is equal to 0. So both of these equations failed to find out the horizontal distance if you don't know the time. Okay, so let's apply this equation. S is equals to ut plus 1 over 2 a t square. So we want to find out the horizontal distance, that is a positive x value because it's a right word, is equals to the horizontal component of velocity times t plus 1 over 2 ax t square. So we have just seen that the ax is equal to 0, okay, because there's no air resistance. So that's why you can simply make it 0, and you can plug the value here. Horizontal distance is equals to u cos of theta times t. Okay, from the last video, we have seen that the time to cover this whole trajectory is, which in fact I have also tried here, is 2u sine theta over g. You can see I have explained in two methods. Okay, so we can put the value here to find out the horizontal distance. Okay, now we will adjust it. We want to find out the horizontal distance, so you can see here it will be u square. Okay, and I can bring this to u sine theta and cos theta. Okay, 2 sine theta and cos theta divided by g. Now in mathematics, I'm sure you know about it, this is the double angle formula. Okay, this is equals to sine 2 theta. So if you expand sine 2 theta, it is always equals to 2 sine theta and cos theta. That's another thing. Okay, you have to go and consult mathematics book for this. Okay, so we can write it. We will just utilize its importance, its significance, that how this formula is going to help you in paper 2, paper 2 as well as in paper 1A. So you can see this is a horizontal distance covered. Okay, now this equation is very helpful if you want to know what is a maximum at what angle if you throw a ball at which the ball will cover the maximum horizontal distance. So let's find out that as well. Let's say if you are testing at the different angles, that at what angle the ball will go maximum distance away from the point of thrown. Okay, so if you are keeping the horizontal velocity, sorry, initial velocity u, and the g is always same if you are conducting experiment close to the surface of earth or on the surface of earth, then there is only the angle that will change this horizontal distance covered. Okay, so theta should be 45 degrees. Okay, why I'm saying that, because if you plug the value here, then the maximum distance covered will be equals to sine 2 into 45 will be sine 90, and you know sine 90 gives us a maximum value, which is sine 90 gives us 1, so that will be u square over g. So this is a maximum distance covered if the angle is how much? 45 degrees.